Welcome to Tech Surge News, where we bring you the latest in the world of science and technology. In this video, join us as we explore futuristic and groundbreaking tech that'll definitely knock your socks off.
Lithium-ion batteries are what's being used for most of our technological devices. But in recent years, researchers tried to find an alternative that provides cheaper, cleaner energy. Sodium-ion batteries are in the spotlight as they are more sustainable than lithium, has a lower cost and are safer to use. Let us begin with spodumene. It is the source of the 2/3 of the world's lithium. It is only found in a few countries, including the Democratic Republic of the Congo and Australia. It's pricey and there's major worry that there won't be enough of it to meet our insatiable demand for electric vehicle batteries. Then there's common salt, at least 35 kilograms found per cubic meter of seawater, and is found in deposits on land. So there's a question about whether sodium from salt could be used to start replacing lithium in our batteries. And it will solve a lot of problems if it could. So, is it possible? So we went to a company called Faradion to find out. So, we're talking about substituting sodium for lithium. Let's take a closer look at why that works. If you look at the periodic table, it outlines all of the elements that exist. This is a list of all different types of atoms. Whatever we create has to be made from materials found here. So, this is the toolbox we have at our disposal. The way it works is that everything within a column has generally similar properties, but it gets heavier as you go down. So, if we look up here, in the upper left-hand corner, you can see lithium. It is a very small atom, it's only the third one, and just below it, it is sodium, or Na, which has similar properties to lithium, but is slightly heavier. So they didn't just pick an element out of thin air. There are several compelling reasons to believe that sodium could be an excellent replacement for lithium. The sodium-ion battery functions similarly to the lithium-ion battery. Today, lithium-ion comes in a variety of flavors. Today, lithium iron phosphate is very competitive with sodium-ion technology. As a result, sodium-ion is also making headway into passenger vehicles, where lithium iron phosphate is also present. Where the technology is constantly developing, we're catching up to NMC, or nickel-manganese cobalt technology. As a result, the energy density will increase, but it will still be similar to lithium. Faradion began at the end of 2011. It's been just over 10 years. When you look at the route relative to the lithium-ion trajectory, you'll see that improvement has been much faster. And when Faradion first started to work on sodium-ion, it wasn't a very known option as a battery solution. And a lot of people dismissed it because generally, you look at the size of a lithium-ion relative to a sodium-ion, and you see sodium is bigger, heavier, and you'll think it'll never be able to compete. Faradion's work over the last 10 years has dispelled that perception, and we can now see that it is a viable technical solution. Let's take a look at the role that sodium plays in this system. When we look at a battery from the outside, we see positive and negative terminals, which we connect to our electrical circuit. However, on the inside of the battery, those two things are transformed into an anode and cathode, which are electrical connectors that connect to the battery. And between the anode and the cathode is something called an electrolyte, which is normally a liquid. And what needs to happen is to get electrons to go around the outside of the circuit, outside the battery where you need charged particles called ions, to go inside the battery between the anode and the cathode. And it is lithium that travels between the anode and cathode in a lithium-ion battery. And in a sodium-ion battery, sodium is the one doing that job. So that all sounds very simple, but it's all in the detail. It's all about what goes around it, and that's what determines how effective, efficient, and well it does its job as a battery. In a lithium-ion battery, the lithium is in the cathode, the electrolyte and the anode is made of graphite. In a sodium-ion battery, the cathode replaces lithium with sodium. Hard carbon is used as the anode rather than graphite as electrolyte for sodium. Because we use hard carbon as an anode rather than graphite as in lithium-ion, we have a broader range of electrolytes available to us. As a result, graphite limits some of the lithium-ion electrolytes that are available with the hard carbon anode. As a result, we can regulate our operating temperature over a broader range. So, for example, minus 30 degrees Celsius to plus 60 degrees Celsius. As a result, these are actually safer in terms of temperature.
Let's take a short break real quick. If you're enjoying the video so far, then why don't you give us a comment down below, because we at Tech Surge News would love to hear what you think. Also, it would be greatly appreciated if you subscribe to Tech Surge News while you're down there. On to the video.
Faradion also has a residential energy storage system, which is a large battery that can be installed in your home, take energy from solar panels, and is filled with these sodium-ion battery products. The markets for sodium-ion batteries are extremely diverse, but the easy alternatives in the market in which Faradion already operates is fixed energy storage. Faradion is already transporting products to Australia and has a joint venture there. They have products used in entry-level markets for telecom, utility, and grid. They also have products for Ferrari that are considered on the big, heavy standstills, go slower and moves fast market. In terms of energy density, the present generation of sodium-ion cells are comparable to lithium-ion phosphate when viewed by consumers. At the cell level, we're talking about an excess of 200 watt-hours per kilo. That is greater than the energy density of lithium-ion phosphate. So sodium-ion is being used as a substitute for applications that use lead acid and lithium-ion phosphate batteries. And there has obviously been a lot of discussion recently about the use of lithium-ion phosphate in vehicle industries. It is always exciting when a new technology works, but a lot of questions need to be answered. Questions such as, is this new technology affordable, available to everyone, sustainable and recyclable? These are the factors that will decide whether these solutions are truly practical in the future, and they will determine whether the sodium tortoise will outpace the lithium hare. Sodium-ion batteries can be recycled in the same way that lithium-ion batteries can. We can completely discharge the cell to 0 volts, allowing us to extract all of the energy from the cell and short it. That is not possible with a lithium-ion battery, so when you bring a lithium-ion battery in to repurpose, it always has a 30 to 40% state of charge. On the downside, because we don't have the expense of raw materials, there isn't as much to recover from urban mining. The way an end user uses their battery will not be any different. What they will be able to see is the potential cost savings with sodium-ion, which any end user for sure will appreciate. The price difference between sodium-ion and lithium will be substantial. Sodium lacks expensive raw materials such as lithium, cobalt, copper, and graphite, which makes it safer for the environment. It will be about 24 to 32% less expensive per cell than lithium, which is quite significant. It is now significant to mention that there is more to Faradion than what we can see. They have manufacturing facilities all over the world. They are currently utilizing a significant amount of lithium-ion manufacturing capacity, but they are about to begin doing their own manufacturing. This company is much more than meets the eye. At first, Faradion had to explain why sodium-ion was valuable, but now it's more about being able to invest in expanding the technology. Right now, the equipment lead times have the greatest impact on timing, and this is where some supply chains come into play. When it comes to the grid or telecom energy storage, these are very active conversations, and Faradion is already building demonstrators. They already have products that are being shipped. If you look at buses and trucks or passenger EVs, Faradion is already involved with them. But the timeline is a little further out. It is critical to maintain contact with them because you do not want to develop technology in isolation. To truly advance the technology, you must collaborate with the major players in that space. The most exciting aspect of sodium-ion batteries is that they are here and ready right now. This is no longer in the laboratory. This is currently in production. These are genuine goods. These are being distributed to customers, and the potential is enormous. So this is an extremely intriguing technology. We're generally fascinated by this concept. It's critical to understand that there will be no single battery to rule them all. However, if there are options made of more common materials, that is a huge deal, and especially if the materials are less harmful and less damaging to extract from the environment, both in terms of environmental and human costs. And so this appears to have enormous potential, and it will be very interesting to see how quickly they can expand it and how far it will go.
Thank you for staying around till the end of the video. To keep on hearing from us, feel free to subscribe down below and hit the bell button to get the latest notifications. Tech Surge News signing out.